Hello, Math 8. So I'm sorry you've had to learn math with videos this week. We are going to be looking at a little bit easier lesson today on similar shapes and scale factor. I'm probably going to end up doing either paper homework or something else, but it's really, really important that you guys did two things this week. That you did Tuesday's edge elastic, because that's going to be on next 9 weeks, right? And that you did Wednesday's formative, okay? These are the two big homework grades for the second 9 weeks, because when we come back, we're going to be looking at a unit test like the week after break. So we're working on similarity, so please make sure you're taking notes, following along. I do have tutorials Friday morning and Friday afternoon. And then Mr. Hubbard will update the quizzes and all that next week when we're back for professional development. So please make sure your quiz is finished. If not, come see me. Otherwise, you'll have to take Think Complete and figure it out when Mr. Hubbard gets back. So we're going back into our journey. If something is similar, what that means, okay? So remember, for two shapes to be similar, there has to be a couple things, right? It has to have SAS. So it has to have a scale factor, okay? Number two, the corresponding angles have to be congruent. And the third thing that we need to know is that the side lengths are proportional. Give you the same rate, are proportional. So I would highly encourage you to jot down those three things. SAS, so side lengths are proportional, there's a scale factor, corresponding angles are congruent. So it says, in previous lessons, you learned that a shape undergoes a dilation. The resulting image is reduced or enlarged. The figure is the same. Dilations result in images that have corresponding angles and proportional corresponding sides, okay? Now, if you've got highlighters, I would say get them out, just because I'm going to be using a lot of color to show corresponding sides. You guys actually talked about this last year a lot. But the very first thing it says is triangle ABC is similar. Here's your little sign. To triangle DEF. This can be expressed using this symbolic notation. ABC, so A, B, C, is similar to, so same shape as, just not size, D, E, F. Okay. Corresponding angles. So essentially what we're doing here is we're going to use this sign right here to stand for angle. So angle A is going to equal, let's say that's going to be 30 degrees. What angle corresponds? Which one's in the same position? So same position is kind of what you're looking at. So the same position as A is D. That's also going to be 30 degrees. So I'm going to say angle A is equal to angle D. Okay, then I have to come over and I have to figure out what angle B is going to be equal to. So angle B is going to equal, let's say that's going to be, let's see, I'm going to do some quick math in my head. We're going to pretend angle B is angle 75 degrees. So that means angle E is in the same place would also be 75 degrees. But I just want you to see that these angles are congruent, right? Same size, same measurement, just the angles. Obviously, the shape's different size. All right, how would I find that last angle? Y'all remember this from last year in 7th grade? I know that angle C is going to equal angle F. Okay, I know that. So to figure out what this angle is, I have to add them all together and then subtract from 180. So I have to say 75 plus 30 is 105, right? Then y'all remember that the interior angles of a triangle are going to be subtracted. 180 minus 105, and that's going to give me 75 degrees. So this one would also be 75. So if angle C is 75, then angle F is also going to be 75 degrees. All right, proportional side lengths. So for this one, I'm going to use a color because I need to make sure you're seeing what ratios are proportional side lengths. So essentially, remember, your scale factor is equal to new over original, okay? So I have to come over and say, what corresponds to AB? This is my original shape, DE. My original side length okay? So in other words, if I said this was 4 and that was 8, and I needed to find my scale factor, that would be 4 over 8, and that would simplify to give me 1 over 2, okay? All right, let's do another one. So I'm going to come over and say, what side would correspond to EF? What's in the same position? That's going to be what? BC. So I'm going to say my scale factor is equal to EF. We usually show this little line on top to mean line segment over BC. And if I take this side length, which is considered to be 2, and this side length, which is considered to be 4 for BC, and write it as a fraction, it's 2 over 4, and that's 1/2. Okay, now see, these are the same, right? In fact, I could come over and say, this is going to be 6, and this is going to be 12, and I could do one more pair of side lengths and say that's going to be DF over AC. And guess what? I'm going to get the same exact scale factor of 1/2, because what's the trick with this? The shapes are similar. So you've got corresponding angles that are congruent, okay? You've got corresponding side lengths that are growing at a rate times 2, right? All the way around. That's times 2, that's times 2, and 4 times 8 is also times 2. Okay, now what happens if you take a look at the next section, okay? So now we're looking at this one, and it says, given triangle XYZ is similar to X prime, Y prime, Z prime, identify the corresponding angles. Now the problem here is, do you see a pretty picture? No. So in math, if you don't see a picture and you need a picture, you're going to draw it. So I'm going to draw a triangle. And I'm going to say X, Y, Z. Then I'm going to draw, it can be bigger or smaller. Maybe a smaller one. We'll do a reduction. X prime, Y prime, Z prime. Okay? And I'm just going to draw an arrow like that just so I know that's what it's similar to. So whatever they put first is my original, or where I start. Whatever it has after is where I end. So I'm going to ask the substitute to pause the video, and I want you to take some time and identify which angles are equivalent. You don't even have to tell me the angles that they are, just what letter corresponds to the other letter. So if you could pause the video for about 3 minutes and give students a chance to try 3 and 4. Go ahead and pause the video now. Okay, so now we're going to talk about congruent corresponding angles. So essentially, I'm going to change up the color. I'm going to start at the top. I'm going to say angle X is going to equal which one? Angle X prime. And then I'm going to say angle Y is going to equal which one? Because they're in the same position, right? So if that's 30, I'm just making up a number. Y is also the same thing. Angle Z is also going to equal angle Z prime, right? Because those are in the same places. Okay, now I'm going to talk about proportional side lengths. What order do you go in? The way you organize this is huge for us. So I find my dashes, X prime, Y prime. I'm going to put my little line on top. Over, I'm going to say XY. Okay? So X prime, Y prime over XY. That's the same thing as, if I come on over and change colors, Y prime, Z prime over YZ. Okay? I'm going to leave off the line segment for now. Now, what's the last one that I did? I did XY. I did X prime, Y prime. I've got one more side left. Do you guys see it? So that's going to be XZ and X prime, Z prime. So that's going to be... Now, the point of this is not to torture you, but it's to show you how you can pull information from two triangles to very quickly try to find the scale factor. Okay? All right, so on the next page, it says, given that quadrilateral JKLM and quadrilateral WXYZ are similar figures, what other measurements can you determine? So I want you to study the pictures and figure out what else you could find with just these three numbers, okay? Is there a corresponding side missing something, okay? And then see if you can find out what that measurement is. So I'm gonna ask the substitute to pause the video to give you guys a chance to actually figure out what you're missing on this picture and how to find it. So if you could pause the video now, that'd be great. So I'm gonna come over, and I know that JM is here, and what corresponds to JM is WZ, so that's gonna be an X. So I'm gonna come over and I'm gonna put, doesn't really matter what order I do it in. So I'm gonna start with X, WZ, and I'm gonna say X over what side corresponds to X, 21, equals, what's the base of this? WX, which is 3, over, what is it over? 9. And then I can go ahead and I could either simplify this down to 1/3, and very easily, because I'm dividing by 3, say 3 times 7 is 21. So 1 times 7 is going to give me 7, so I know my answer is 7. Or I could look at this picture and say, I know that's a times 3 relationship because 3 times 3 is 9. So what number times 3 is going to give me 21? I just divide it back and I get X equals 7. Now I really can't find anything else in the picture because there's no angles that are listed here or anything. So I just wanted you aware of that. All right, so it says we can use proportions to find the missing lengths of similar figures, but did you know that we can also write proportion to show the relationship between similar figures and their corresponding side lengths? So essentially what this is saying, first of all, is you're not always going to get shapes that are exactly the same position on star like this. They're going to tilt them up like this. So before you set up the proportion, I'm going to ask the sub to pause the video so you can redraw this facing the same direction as triangle ABC. Otherwise, it's going to be pretty hard to set up what we're missing, okay? So if you could pause the video now, that would be super great. Okay, so I'm going to go ahead and write a smaller one of this. Draw a little bit as straight as I can. And then this is going to be D. That's where my little squiggle is. And then it's going to be DEF. So D, E. And I know that DF is 3. So I'm going to put that right here. This 3. And then I know that EF is 4. Okay. And so I'm just missing that side length. Now to use a proportion here, I'm going to kind of scooch down here. Let's assume I was trying to figure out a proportion. So remember, I need to find out my scale factor, or I want to find out my missing one. That's always my new side over my original side, right? Okay? So I'm just going to think about it from here to here. So if I was going to look at my side length, I know this is 3. So what corresponds to 3? 6. So I'm going to put 3 over 6 because I'm basically going like this. This was my starting picture, triangle ABC. So it's new over original, okay? Then let's check another side to make sure it works. Then I'm going to come over and say 8. And I'm going to say 4. Now what's my new side? That's 4. So it's going to go on top. So 4 over 8, okay? Now what do all of these simplify to? A scale factor of 1/2, right? So if I come on over and I want to figure out what this side length is right here, I can set up a proportion. So I could say question mark over 4 equals, so I'm going to do that. What corresponds to it? 12 over what? 8. And then just like you talked about last week, I can say 4 times 2 is 8. So what times 2 gives you 12? That is typically an X we use for that, and that means X is going to give you 12 divided by 2, or 6. Makes sense because the shape is actually a reduction of the original one, okay? So when writing a proportion to represent the relationship between corresponding side lengths, it is important to remember that order always matters. Always matters, okay? So essentially what that means is it's always going to be your new side length over side. Okay? Now you need to make sure that you're always doing your new over your original. Okay? Those two corresponding sides equaling your new over the original side, or we're going to run into problems. Okay? All right. So the big takeaway, are two shapes similar? Okay? You can set up a proportion, but the order always matters how you set it up to make sure that you can get the best answer possible. Please, I'm going back to the front. Make sure that I've got the edge elastic informative for you. And then I'm going to try to see if I can come up with another assignment for similarity that I'll post in Google Classroom, because I need to make sure we're really good on similarity by the time Mr. Hubbard comes back after fall break. All right, come see me Friday morning if you have any questions. Have a great